Welcome to Configuring ScreenOS Firewalls. This is the session on address translation. As we discussed in the earlier sessions, address translation and port translation are basic features required of a firewall, so these features are available in ScreenOS. And in ScreenOS we have a number of different methods for doing address and port translation. So we'll be reviewing those options and the scenarios in which those options are applied. So at the conclusion of this session, you should be able to understand and describe the scenarios for policy-based translation. You will understand that outbound in one direction can be done by policy. Inbound in one direction can be configured by policy. And bidirectional translation, both inbound and outbound, can be configured in the same policy. You can configure policy-based translation of the source addressing, NAT-source, NAT-destination. You can use virtual IP addresses, the VIP feature, and you can use a mapped IP address, the MIP feature. And we will review the methods to verify that NAT operations are occurring. So these are the objectives for this session, and all of this material is part of the JNCIA exam. So this is our organization. First we'll discuss the scenarios where address translation is necessary. Then we'll go over source address translation, destination address translation, the VIP feature, and the MIP feature. So beginning with the scenarios. Network address translation is the changing of the source or destination IP address as it transits through the device. PAT is the translation of the port address translation. So either or both of these is required in some scenarios. The use cases are internet access. In most scenarios, we have the private non-routable addresses in use on the inside of our firewall, and those, since they are non-routable, they have to be translated to a routable address by the firewall device in order for internet access to function correctly. And this also involves port translation, so the firewall can use a series of a pool of high ports in order to distinguish the multiple hosts behind the single IP address. We also use address translation in order to take an internal address of a server and publish it from the private network into the public sphere through the firewall. And we also use address translation in order to hide private addresses on our side of the network from perhaps multiple private addresses from a remote network behind a single IP address. So that single IP address can be either private or public, and these address translation scenarios are used to simplify cross-network connections. There's a limited pool, of course, in the private addresses we're allowed to use, and when we connect to other company networks, there's sometimes an overlap in those addressing where we're using the same address as them. The network address translation allows us to change addresses to something unique for both sides in order to allow computers or servers on the two different company networks to successfully communicate with each other. And it also then allows multiple computers, it can allow multiple computers on my network to use a single address to communicate with everything on the remote network, so that they only have to reserve one IP address in that private realm instead of however many computers or networks we need to connect. So ScreenOS offers a number of methods in order to do these translation options. As we mentioned in a previous lesson, there is a basic interface NAT which can be used in certain circumstances only from certain zones in order to provide internet access from the device. And that's set up by default in those default methods on a device that's the branch size. If you're going in one direction, if you're doing the translation in one direction via a policy, you can translate your source, you can translate your destination, or you can use port forwarding, the virtual IP address. The virtual IP address allows you to use the single public IP address and send different ports to different servers. So you can send, say, FTP to one server, HTTP and HTTPS to another server, SSH to a third server, where a single port can go to a server, and each of those port forwarding can go to a different server. You can also do this through policy, but VIP is the special feature to do straight across port forwarding. And then there's the mapped IP address, the MIP. This is a one-to-one IP address mapping, and it is bi-directional. So if you have a server that you want to have mapped for both the outbound and inbound traffic, say a mail server, SMTP, where you want the outbound traffic and the inbound traffic to appear on the same public IP address, and the public IP address is going to be dedicated to that server, then you can use the MIP function. Okay, how does policy-based NAT work? We've seen this as a policy option in the previous sessions. So you can apply NAT inside a specific policy. So it'll only do the NAT when the traffic matches the conditions you've set up in the policy for source, destination, and service. And the options then for this are to do source translation. So in this scenario, in a NAT source, you would see that the source IP address for this traffic here is changing from 10.1.10.5 to 1.1.1.1. And as you can see, that is the interface address of Ethernet 00. So this computer on the left-hand side, 10.1.10.5, is making a request to that server 200.555 on the internet, and it's being sorted for or NATed to the source IP address, and this is an outbound direction. The next example we're going to look at is destination NAT. Here the request is coming from the server on the right. It's an inbound direction. It's making the request to the IP address 1.1.1.1, and then that is being translated to the new destination address 10.1.10.5. So that's destination NAT. In VIP, the port forwarding virtual IP address, this is also then in the inbound direction, and we see it does exactly the same thing as NAT destination. So these two functions, NAT destination and VIP, in this case, can perform exactly the same thing, but they're just configured differently. But functionally, on the processing of the IP, they're performing the same function. This 1111 destination is being converted to 10.1.10.5. And then finally we have our MIP example, and this is bidirectional. So when we configure a MIP and this traffic occurs, the mapped IP address will, in the top case, translate the destination of the inbound traffic from 10 or the outbound traffic from 10.1.10.5 to 1111, and the inbound traffic from 1111 to 10.1.10.5. So there's then a one-to-one relationship between those, and in using a MIP, that cannot be the interface address because it's dedicated to the server. So this would have to be 1112 or some other address that is able to be handled by the interface. Okay, so what are our use cases for these different scenarios? We saw that some of these functions are performing the same technical function. What are the recommended use cases for each of these types of configurations? If we're going to use policy source NAT, this is recommended for sessions that are initiated from a private to a public network. So instead of using interface-based NAT, policy-based source NAT is recommended for all your traffic that comes from private addresses and goes out to the internet. For destination NAT in a policy, if you have a single public address and you want to map it to multiple hosts on this service, the policy-based destination NAT is recommended for this. Host services can then be accessed from the internet, but the host will still have to access a different policy for internet access. This is just destination NATing to the inbound. So this is good for things like web servers or others that are not initiating the contact to the outside world. The VIP is the recommended simple configuration if you have a single public IP address, particularly the public IP address of the interface connected to the internet, and you want to map it to multiple hosts as port forwarding. So this again is the same type of function that we're doing in destination or source, destination policy NAT, and these are alternatives to each other. And then the MIP is required if the server cannot share a public IP address with other hosts, and you want bidirectional traffic. Now you can configure NAT source and NAT destination into a policy so that SMTP or any other service can always be sourced from the same address. So you can achieve the same thing as MIP, but MIP allows you to do this in a single step, but it does require that the IP be dedicated to the server. So if you need to share the IP among multiple servers and you're doing outbound has to go to a particular IP, you can create the outbound policies that change the source and inbound policies that change the destination and achieve the same functionality and share the IP address using policy-based source and destination NAT. Okay, so let's talk about how we achieve these functions. We'll deal with source NAT first. Source NAT can use dynamic IP addresses. A dynamic IP address, a DIP, is used when the egress interface IP is not sufficient for your source translation. You can always select in your policy the egress interface IP address to be the IP address of the source. So whenever that's possible and appropriate, you can use that. When it's not, you'll need to create a dynamic IP address object in order to do the translation to that object. So you may need these if you have a range of public IP addresses assigned to your device. Naturally, only one of them is on the interface. And if you need to do that source translation of the SMTP server to a different address, as we mentioned earlier, then you'll need to configure a DIP in order to have that policy use that public IP address for the outbound traffic. The DIP can be a pool or a single address to be used in translation policies. You create the dynamic IP address, the DIP, on an egress interface where it will be used. And when you create them, there are options that you have in the subnets. They can be in the same IP range as the primary IP address. They can be in the same IP range as a secondary IP address configured on your interface, or they can be in any IP range whatsoever, which we refer to as an extended IP address. So when you create the DIP on the interface, it can be in any of these scenarios. And multiple policies can use the same DIP address or pool. Once that DIP is created, you can just use it and select it in multiple different policies. Okay, there are various options available for configuring source NAT. When you're using the egress interface, it will use the interface IP address, and it will always do port translation. So this option to select the egress interface is equivalent to the interface-based NAT that we discussed in the private lesson or a previous lesson. So this is the standard method then for a whole bunch of computers on a private network that are just going to share an egress interface for internet access. When you use a DIP for this, if you're creating a dynamic IP address, you can do it without port translation. If there is no port translation going on, then the outbound address will come from a pool of addresses that you created. It can be a pool of one. It will preserve the port selected by the original host, and it will translate just the address, and then you can only, of course, have one host per address in the pool. So if you create a pool of one, you can only use that address for the same host in every policy that you apply it to. Because it's not translating the ports, it has no control over generating a whole bunch of random ports to distinguish multiple hosts. So when you create a DIP that does not do port translation, you are telling the system, I am going to manage a one-to-one relationship between this dynamic IP address and the internal host that it is being assigned to. So this essentially is how you use a DIP like a MIP and have fine-tuned control policy by policy on exactly what's going forward on it. Now the second way you create a DIP is to behave like this egress interface one, the DIP with port translation. You can again have a pool of either one address or multiple addresses, and it will do port translation, so you can use it for a single address for multiple hosts. So this with and without port translation is an important distinction, and it's a design distinction. So you have to lay out first how your network is going to operate and design your address translation scheme. Are you going to be assigning your IP addresses server by server, host by host in your network, or are you going to create this is a pool that all of these types of hosts can use, and this is the address pool or single address in a pool that I'm going to assign to it. So this is a design decision. Now, to simplify things in larger networks, your DIP address pool can do address shifting. So suppose you have a subnet, a public subnet that's a whole bunch of servers. Maybe it's a /28 or a /27 or even a /24 set of addresses in a large server farm, and you're going to have a server at every one of those addresses. It's a secondary subnet just for your server pool, and there's a one-to-one relationship between all those addresses. You can then create a DIP pool that shifts the address, takes all the 10/10/10 0/29 addresses and shifts them to 208.79.13 0/29, whatever your carrier is assigned to you, and it just takes all those internal addresses and one-to-one maps them with an address shift to your public address space. You can do that in one fell swoop by creating the DIP that does address shifting. Okay, so let's take a closer look then at how these scenarios then play out. If we're looking at the type of address translation, the source and destination address, original, and then what happens during the translation process. So here we have policy-based NAT source translation. The source address on the left is 10.1.10.5. It had a randomly generated port for the request of 1099, and you'll see that changed when the translation occurred. It went to 1111, our interface address, and it assigned it randomly the port 1024. No change at all on the destination address. If you're using the DIP with port translation, say we have two hosts now, 10.1.10.5 and 10.1.10.6. They make their request. They're both sharing a DIP, and they both get randomly assigned two different ports then in order to distinguish them as the DIP. So the DIP is 11110, and 11110 is using port translation in order to share that single address with multiple hosts. When you create the DIP with a fixed, there's going to be a one-to-one relationship then between the host and the DIP address, and the port is not going to change. So that 1099 port, 10.1.10.5 with a port of 1099 is going to change just the IP address to 11110, and the port's going to remain at 1099. And this DIP is assigned to this internal address. And then here's our IP shift. if we've created an IP shift pool, 10.1.10.5 is shifted to 1.1.1.10, 10.1.10.6 is shifted to 1.1.1.11, and if we continue, 10.1.10.7 would be shifted to 1.1.1.12. However big you create the pool. So this is how the source translation examples will play out based on how you configure the DIP. Is it NAT source on the interface? Is it a DIP with port translation, a DIP with fixed port, or an IP shift? And in the IP shift, we're also not changing the port. Okay, so let's take a look at how the configuration of this will occur. The first step in doing source NAT by policy then will be to create the DIP. If you're going to be using a DIP, it will have to be available to select in the policy, so that will be the first step. When you create the DIP, you will need to choose whether or not you're doing port translation or address shift, and you will do this on the egress interface. After that's done, you simply go in and create the policy. So if you're not using a DIP, if you're using egress interface, you go right to policy creation. Egress interface is selectable without any special configuration necessary. Okay, to create a DIP. DIPs are created on the egress interface. So set interface, Ethernet 00 DIP. DIPs are assigned a number in order to keep them apart. In this case, DIP 4 and DIP 5. 1.1.1.10 is our DIP, and 1.1.1.15 is the end of the range. And we can say fixed port. If you don't say anything, it's going to do the port address translation and be shareable. So if you say nothing, there's port address translation. If you add fixed port, that means it'll lock the ports. And then the DIP shift from 10.1.10.5 to 1.1.1.10 to 1.1.1.15. So that's a 5 pool shift. 5, 6, 7, 8, 9. So these are the commands to perform that on the command line. In the web interface, since these are on the interface, there will be a tab. When you go to the network interfaces, you edit the interface, and then you select the DIP tab and hit the new button. With the new button, then you have to select which IP range that the DIP is going to be in, whether it does port translation or fixed, and whether or not it's a shift. You select the parameters that the DIP is going to done, and the ID number is randomly assigned in sequence at the top, starting with ID 4. Okay, now that we have a DIP available, we can create a policy. And we add the keyword DIP and the number into the policy statement, or you can enter the policy on the command line if it's an existing policy by set policy ID and the number, and just do set DIP for inside that policy. In the web interface, you go to Policies, Edit, and once you've edited the policy, then you go to the Advanced tab. So in the Advanced tab, there's this section for NAT, and you're going to check off Source Translation, and you select your DIP from the pull-down list here. The first item on the pull-down list that is always available is Egress Interface. So it's done in the same place there, but instead of DIP 4, it'll say Egress Interface. In order to see whether a DIP is in place on the command line, we can do get DIP, and it'll list all the DIPs and what interface they were created on, and their properties. And on the web, we go back to that same area, network interface edit, and when you go to the first screen on the edit, before hitting the new button, it lists all the dips that are created on that interface and their type. To verify that the source translation is taking place, we can use the get policy ID to see how the policy is configured, which we've seen in the previous sessions. And we can also go to the sessions for that policy. So get sessions for policy 1, and when you have the session listed here, part of what the session lists in the middle there, you can see the translation occurring. The 192.168.128.10 address is being translated to 98.111.198.54 before being routed out to that internet address. On the web, you see these on the policy itself. This blue icon here indicates that the translation options have been activated on this policy. It'll be just either green, standard green or red for permit or deny. When it's turning blue, we have NATing operations applied. If you click the logging icon, you get to see the sessions, and then here we see a session with the original source address on the right and the translated source address or on the left, and the translated source address in the middle there. So the destination remains the same, that's a DNS request, and the source gets translated from the random port 192.168.128.10 with a port of 36,311 to 98.111.198.54 and a port of 1385. So the logging, you can see this on the web, and by looking the details of the sessions that are active, you can see this on the CLI. Okay, the other direction is destination translation for inbound traffic for our servers and the like. In order to configure this, we have some options. We can do the one-to-one mapping of a single address to a single internal address. We can do a one-to-many operation where a single address gets sent to multiple servers. And we can do a many-to-many, which is that address shifting, where we take a public subnet and shift it into an internal subnet. And again, port translation can occur on this by option, although typically you're going to be doing this for servers, so you probably won't be translating ports, but you may need to use port translation if, say, you have only one public IP address and you have two web servers. They both can't use port 80, so you might publish, tell people to use a URL with a port of 8080 for your web server, and then on the inbound destination for that, change the 8080 to 80 before delivering it to the web server itself. That way you can sneak another server in on the same IP address. Okay, so these are all inbound traffic from internet to internal. And when you have a one-to-one arrangement, that means this 1.1.1.10 is going to land on, in this case, on 10.1.10.5. And the port will stay the same for this FTP request. If we have one-to-many, we can split them so that the port request for FTP goes to that 10.1.10.5, and the request for SSL goes to 10.1.10.6. And we can do port translation, where we tell people to use this port 2020, and we redirect 2020 to 10.1.10.5's port 80 for a web server request. Or we can have our IP address shifting. So in this case, we have two addresses that are shifted to two internal addresses. So the 1.1.1.10 and 1.1.1.11 go to 10.1.10.5 and 10.1.10.6. So these are all examples of how this inbound is going to work. Okay, so here are requirements in order to set up this inbound one. When you're creating the policies, pre-translation address, that means the address that's actually used in the request that's hitting the firewall. So the pre-translation address has to be in your destination zone. So when you create that address object and you're going to design your policy is going to be from a zone to a zone. When you create this address object for the original request address, you're going to create it in the zone that you want to have the policy to. So, for example, if you're going to write a policy from untrust internet to trust internal, then you would have to create that public address that's assigned to this server in the trust zone. So I know that's counterintuitive on some levels, but if you're going to write the policy from untrust to trust, then the pre-translation address has to be in the trust zone. Now you can just as easily create the same access as an untrust to untrust policy, in which case then the public address is created, the public address object is created in the untrust zone. But when you create that address object, you're making a decision as the zone-to-zone policy that you're about to create. So your pre-translation address object needs to be placed into the destination zone that you're going to write the policy for. So once you have that address, you create that address book entry in the zone you've decided you're going to write your policies. Now you need a route. So you need to make sure the routing table has an entry in the same zone, because remember, when our packet flow process is going to evaluate, do I have a route to this address before it evaluates whether or not to find a policy. So that the firewall must have a route to the public address that's in the policy, and the route is going to tell the ScreenOS device where to look for that. So again, if you're going to write a policy from untrust to trust on this public address, you're going to create your address book in the trust zone, and you're going to write a /32 route for this same address to the trust interface where that server that you're delivering the translated address lives, so that all of this packet flow that we discussed earlier works correctly. So if it's untrust to untrust, then that /32 route's going to go to the arrival interface where the packet's coming in. So it's neither way is right or wrong. It's just whichever way you choose, you have to be consistent in creating these objects to the right zone and the right interface. Okay, when you're doing this destination policy, this address cannot be shared with the interface. So if you're doing it using the interface IP, you have to use the virtual IP address. Okay, how do we configure destination NAT policies, NAT-dst? You're going to create the address book entry for the public IP address. You're going to create the route entry for the public IP address. You're going to configure the proxy ARP settings on the public interface so that that IP address will be responded to. An alternative here would be to have this IP address configured as a secondary IP address on the interface. You're going to configure your policy options to use the translation type and the port mapping that you've selected for this. So you're going to prepare for your policy by creating your address book, your route entry. You're going to make sure proxy ARP is set up, and then you create the policy, selecting all of these objects as you've designed them. Okay, the entry for the public address in the destination zone. We're going to go to the address book, and in this case we're going to set the, we're going to do a untrust to trust example. So we're going to set in the trust zone our FTP server's public address 1.1.1.10. This we reviewed earlier in the previous lessons is the same process. You'll go in there and either in the web or on the CLI create the address book entries so that it's selectable when you do the policy. Now we're going to configure the static route, and this is a repeat again of what we've learned in the previous lessons. We're going to use the set route command for the same address, and in this case our trust interface where the server is B group 0, or we go into the network routing destination, and we create the new route to the B group interface. Proxy ARP is configured on the interface. This allows the untrust interface to respond to those ARP commands from the carrier for addresses that are not configured on it. So in 6.2, if you just set ARP NAT-dst, every time you create a policy, it will automatically ARP for that particular request. In 6.3, these are created per address on the interface in question. Set interface Ethernet 00, proxy ARP entry 1.1.1.10. In the web interface in 6.3, you would go to the interface itself, and there's a proxy ARP tab where you can then create a range. So if you're going to use all of those addresses in your range, you can create it in one fell swoop and assign proxy ARP to all of the addresses that you intend to use on the firewall. Okay, now that we have all our pieces in place, we can create the actual policy that does the address translation. So in the policy configuration, you're going, in this case, from untrust to untrust. Any address on the internet hitting our FTP server address object that we created, using the FTP port, translating NAT-dst, NAT destination on to the IP 10.1.10.5, and permit the traffic, and we're going to, in this case, log it. We create the policy the same way we saw basic policy creation before, from untrust to untrust, a new policy, and into the advanced tab. And on the advanced tab, we are going to put the destination translation and the IP address. So that's the basic tab on the top and the advanced tab on the bottom to do the destination IP address. Okay, verifying that we have configured NAT-dst, destination natting. We get our policy again, as we've seen previously, and we can see that the policy is configured as we expected with a destination NAT map on there. And we can look at the sessions, and we can see that the inbound sessions are being translated from the 1.1.1.10 to the 10.1.10.5. On the web, again, this icon indicates that translation is occurring. And if we look at the log, we can see that the inbound translation is taking place. Okay, now the special function, virtual IP address, which allows port forwarding to be configured on an interface and multiple servers to use a interface IP address or another IP address that's been publicly assigned to your server or to your firewall. In order to do the VIP configuration, this is a one-to-many configuration, so that addresses can be a single address can be forwarded out to multiple servers, but one port cannot be shared among different servers. So every port goes to a different server. You know, SSH, HTTP, HTTPS, etc. can all be sent to separate servers or the same server. You define a VIP on the interface where the traffic arrives on the firewall. And this is an example of how you would set up the VIP for 1.1.1.10, and you would choose port 21 to go to one server, port 80 to another, and 53 to a third. So we can have our FTP, our web, and our DNS server, all separate servers, but sharing the same IP address. And then after you've created the VIP, you have to create the policy that allows the traffic. And you'll see that when you create VIPs, you have a new object available in the address picking of policies that'll say VIP on it. So VIPs get created on the interface in which the traffic arrives and is handled. So here's our three, port 21, 80, and 443, going to servers 10.1.10.5, .6, and .7. We create a VIP forward then on Ethernet 00 for all three of those. And then on the web interface, this is again a tab on the interface itself when you choose edit. And you will, when you hit add a new service, it'll create the virtual IP address, or you can do it on the same IP address as the interface. And then you set up where it goes. So in this case, we created a VIP on an IP address in the range of the interface that our carrier gave us, and we're forwarding port 21 to 10.1.10.5. Server auto detection allows the firewall to make a check to see if that server is up and running. This is just a straight up ping. It's not doing any kind of policy checking or anything, but it's seeing, is that server there when I activate this. So once the VIP is created, we're going to need a policy to allow the traffic. Otherwise, by default, all traffic is denied. So same policy command we've been using all along, and instead of a address object, we choose the VIP, and the VIP is in that format of VIP and the parentheses of the address that we created. And then in this case we have any service, but you can select service by service to allow this traffic. So we would say, FTP, HTTP, or HTTPS instead of any on the service there. On the web, this is still the same. You're going to select your untrust to trust and a new policy, and you're going to select that VIP as your address book entry, and you can narrow it to your service or select your multiple services here. In order to verify that the VIP is configured, we're going to go use the command get VIP, and it will return the list of all the VIPs that are configured in our system. Or we go to the interface itself. On the VIP tab, it will list the IP address and the ports, virtual ports that are created on that IP address for us. So every new address will have a new row in this table, and then multiple sub rows for the ports that are configured. In order to verify that the operations are working correctly, we can go to the global get address global. VIP objects are created in the global zone that we had mentioned earlier. So in this case, it's an address object in the global zone so that it's available everywhere you want to configure a policy. And so there you can see that the address is available and created. And of course, to actually see the traffic, we go back to our get session policy number, in this case policy 2, and we can see that the translation is indeed occurring for the policy we configured. On the web, you will see that since we're not doing policy-based NAT, our action is permit, so it's the green arrow. And we go to our logging to see that the address port has been translated. The destination port has been translated from our 1.1.1.10 to the 10.1.10.5. Okay, so we have mapped IP addresses. This is our bidirectional function for one-to-one mapping of a public IP address to an internal one. In order to configure MIP, you design your one-to-one static mapping. Then you're going to be able to use bidirectional traffic then on that. You're going to create the MIP on the outbound interface where you want the translation to occur, and then you're going to use that created MIP in the same way that you did the VIP in the associated policy. So it's a very straightforward process and pretty much the same as using the VIP, only it's bidirectional. So to create the MIP on the interface, we go to the interface property, set interface Ethernet 00, MIP 1.1.1.11, host 10.1.10.8. So we've assigned this public address to that internal address. This is again interfaces, so we're going to edit the interface, go to the MIP tab, choose new, and fill out the form. And that gives a one-to-one single address translation based on the net mask. If you're doing ranges or multiple, you just change the mask in order to spin up the whole section. Once the MIP is created, we create our policy the same way we always do by set policy command, zone to zone. And instead of an address object, we have MIP and the address in parentheses. And we can, like this case, we're using any service, but we can, of course, do the same service, multiple selects, service groups, etc., that we learned about in basic policies. On policies, again, this is the same process, and you'll notice the address book entry has the new address object called a MIP in order to be selected there. And the rest of policy creation works exactly the same way that it always has. So in order to verify that these objects are in place, we use our same get session policy again to see the actions that are occurring on that policy, in this case policy number 3. Or we go into our web interface, and again we see green permit with a MIP address. We select our log, and we can see that the translation is indeed occurring on this address, changing the destination from 1.1.1.11 to 10.1.10.8. So you'll notice all of these verification operations, as you can see, are consistent procedures across whatever method we're using as the translation method. Okay, we mentioned that you can shift a whole bunch of addresses at the same time using the MIP command. To do this, we will use the network mask, as I mentioned earlier, to specify the range. So this will all follow all the standard CIDR rules for network masks. For example, if you have 1.1.1.8/29 as your assigned range, this is how that translation table will play out in a 10.1.10.96 scenario. So to configure a MIP with a mask, we're going to go in on the interface as before, and instead of the just a host 1.1.1.8 10.1.10.96, we just add the keyword netmask and put in the mask. So here's our /29, and now we have the entire range translated one-to-one for the whole subnet. In this interface to create the MIP, we just change the mask from 255.255.255.255 to the 248 in the last octet, and it will spin up the entire range. Okay, so we've mentioned that there are multiple methods here in order to translate addresses. Suppose you're using all of these methods, and you've somehow managed to configure the same addresses in the methods. So what's the order of precedence? The MIP is going to take precedence over everything. So if a MIP is configured for an address, that will be used first. The VIP is secondary to that. So if a VIP is configured, that will take precedence over the rest. And then policies will apply in the order that they are seen in your policy ordering. So just the same as we mentioned earlier in creating policies, order matters. The first match in a policy and you're done. But MIPS and VIPs will occur prior to policy-based NAT. And then finally, interface-based NAT is the last on the list. So it will only be interface-based NAT only works in the specified scenarios we talked about earlier, and it will be the last type of NAT applied, only if none of the other NAT is configured. So reviewing address translation, at the conclusion of this session, you should be able to describe the scenarios that you would use for policy-based NAT translation, which are the unidirectional outbound, unidirectional inbound, or you can configure policies both to translate in both directions and even in the same policy. You can configure translation for NAT-source, NAT-destination, or the virtual IP address for port forwarding on addresses, or you can use the mapped IP address for a one-to-one relationship between public IP addresses and internals. So you should understand what each of these 4 options are. You should be able to verify that NAT mode operations are occurring. So these are the goals of address translation. It's a lot of different methods, and you can use them in any combination that you desire for your network design. If you have any questions, you can post them in the public forum or comments or clarifications. Feel free to engage with the material of the course there. If you're not comfortable doing things publicly, you can contact me through the contact information on the course website, and I'll be happy to respond to your questions about the course material and in any way I can. I thank you for your kind attention in this, and hope that you found the sessions helpful.